So that's one of a longer domain. We don't see this very often in the purple there. We do see a lot of stuff in the blue. Okay, Miles, you know this class starts at 12, right? Like not at 1.
I I got my schedule very mixed up. I am sorry. That was my mistake.
Well, it's it, it it's every day, buddy. That's why I said something today, because this is
Okay. Yeah. So clear I thought so I did not. Okay, yeah, I genuinely thought
That's
this
okay. No, I
started at
wasn't
one.
trying to
Yeah,
be a
that's my
jerk. I
bad.
was just like, because it's not that you're not late at 1.
Yeah.
It's like,
Yes, I really had that very mixed up. I'm sorry.
yeah, yeah, no, I just didn't. So, like, my son's in a different time zone. Both of my kids are in well, the two big boys are in different time zones. So, if I tell them something's at 12 o'clock, they're like, your time or my time? And since this is a virtual class, who knows what time zone you're in, right? So it's like, no, no, it's
Yeah, my
Eastern.
bad.
We're in Eastern time.
Okay.
All
I'll
right.
make sure to be at 12 on Eastern time. I'm sorry.
Yeah, no worries, hon. All right. So, like I said, the purple, not very common. That would be like a really crazy problem to have that many domain restrictions. A lot of times you will see the domains like the ones written in blue. So the one here written in blue is probably the most common domain restriction problem that we would have to write for in interval notation. Okie dokie.
Yep.
The purple is just a longer version of the blue. You just there's more things to skip in the purple. But the blue is there's things to skip, just less of them. All right. Any questions? Because now we are going to just keep using interval notation to do our domains. All right. We're just going to solve the inequality. So right here, I'm just actually going to make this so it fits on the page as one big problem. All right, so we're going to solve each inequality, graph the solution set, and write the solution in interval notation. Okay, so all we're doing is solving the inequality here. So we're going to subtract 2x. Let me get x plus 5 is less than 9. And then we're going to subtract 5. And we get x is less than 4. Okay, well, we did one of those, right? We did one of those. So if I'm writing that in interval notation, go up here, it's the orange. Oh, that's from negative infinity, and in this case to 4 though, right? Because we don't use their numbers. So this is from negative infinity to 4. And again, it is less than, not included. You use both parentheses. And if you're going to graph this, in high school, we used open and closed dots. An open circle meant not included. A closed dot means included, which would be your equal tos. Okay, guys, for these graphs, we're going to use either parentheses or brackets. So since it is not included, it's going to be a parenthesis and it is less than. And there you go. Preferably with your line a little bit straighter than mine. But you know what? Squiggly works.
If we forget and we do the other method with the circles, because like we're used to it, will that like make up
So
points?
so that's not for me. It's more for Alex. So when we had our previous software, the homework software, WebAssign wanted you to graph using brackets and parentheses, and it confused students because they were like, but I put an open circle and a closed circle and they counted it wrong. That's because WebAssign was a jerk. For any of our assessments, quizzes, things like that, you will not have to graph any of your solutions. I just showed the graph because the homework sometimes asks for the graph, whereas we do not. So for an assessment purpose, you won't have to worry about graphing, so it won't matter. But if you put an open circle in your homework and it counts it wrong and you're like, wait a minute, try the parenthesis and see how that goes that time. So
Okay,
it
thank
was
you.
for the homework. It was for the homework, not so much. Yes, ma'am.
Does it matter what side of the equation the x is on?
It does not, but since we read left to right, it is easier to do inequalities if the variable is on the left. So this says x is less than 4 instead of 4 is greater than x. 4 is greater than x tends to get us writing things like this. 4 is greater than x if it looked like that. And that's wrong, right? That's not right. So that's the only reason I put the variable on the left, but no, mathematically it does not matter at all. Anything else? Excuse me. Oh, goodness gracious. The fun begins. All right. For our second problem, again, I do like the x being on the left, so, but definitely your choice. I'm going to subtract 2x, so I have 7 minus 6x is greater than or equal to 1. I'm going to subtract 7, negative 6x. Goodness, is greater than or equal to negative 6. I'm going to divide by 6, and this is where, sorry, divide by negative 6, and we are going to flop that inequality symbol. Okay? So when you multiply or divide by a negative number, you need to flip your inequality symbol to the other direction. When you multiply or divide by a negative number, that doesn't mean you have to get a negative. It doesn't matter if you get a negative answer. It's negative number. Okay? Okay? So when you multiply or divide by a negative number, you must flip that inequality symbol. Okay? So even though that was greater than or equal to, I did have to flip it to a less than or equal to. Okay? And again, less than or equal to, but it's equal to, so that's a bracket. And then we're going to go to the left, less than. And then this is from negative infinity to 1 bracket. Questions on that one? Okay. I want you guys to try this third one. Give that one a go. Pardon me. Oop. Yes, that is correct. Not quite, Cesar. Yes, but there should be a bracket and write your answers smallest to largest. Flip the number in the infinity. Smallest to largest. You're welcome. Would anyone like more time? Okay, I'm going to subtract my 3x. So I get 2x minus 3 is greater than or equal to 4. Then I'm going to add 3 to both sides, and 2x is greater than or equal to 7. Divide by 2, x is greater than or equal to 7 over 2. If you do get a decimal, you can get the decimal. That's perfectly fine. Okay. Greater than or equal to 7 over 2, that's 3.5, right? So x is greater than or equal to 3.5. I just like fractions more than I like decimals. So it would be bracket 3.5 to the right. And then 3.5 is the smallest, so it's bracket 3.5 to infinity. And you could write it as obviously the bracket 7 over 2, right? Doesn't matter if you use a fraction or a decimal. As long as you're not rounding decimals, it's perfectly fine to use decimals. Okay. Questions, comments, concerns? Okay. This next one is a compound inequality. This is one of our ands. Okay, so this compound inequality, our solution when it's all said and done, are going to look like these four right here, the betweens. Okay, so the next set of problems we're doing are getting ready to be the between problems. Okay, so this guy is going to be a between problem, and we want to keep the x between the two numbers on the left and the right. But we do want the x to be by itself. So what you do is you look in the middle and you figure out what you need to do. Well, I don't know why you can't hear me. My audio says it is up. Can anyone else not hear me?
I can hear you.
Okay. Well, I
Me
know we
too.
were having issues with audio on Monday, so I'm like, did it go the other way now? Or Tuesday, I mean, sorry. All right. So from the middle here, I'm going to subtract 1. So in this case, I subtract it from the left, the middle, and the right. So the middle goes away there. So I have 1 is less than 3x, which is less than or equal to 9. and this is 3 times x, so the opposite of times is divide. So I'm going to divide by 3, divide by 3, divide by 3, and boom, that goes away. So you get 1/3 is less than x, which is less than or equal 9 divided by 3 is 3. So essentially we are between 1/3 and 3, parenthesis on the 1/3, a bracket on the 3. So bracket on the 3, parenthesis on the 1/3, and you just connect it because it's between, right? It's between those two values.
Is
And
it okay
then
if I break that into two equations?
that is perfectly fine as long as your solution ends
Okay.
up being the same. So then we are between 1/3 and 3 bracket. Yeah, as long as your solution set ends up being mathematically appropriate, whether you break it into two equations or if you solve it all as one, it does come out the same. Yeah, Miles is our tech guru. All right. Any other questions on the red problem here? Okay. All right, let's do another one. Okay. Again, whether you break it into two inequalities or you just leave it alone and let it go. I'm going to leave it alone, let it go. I'm going to add 3. So I've got -2 is less than or equal to 4x, which is less than, oops, 12. And then I'm going to divide by +4 here. And I get -1/2 is less than or equal to x, which is less than 3. Okay. So we're including the -1/2, so that's a bracket at -1/2. Be helpful if I put it in the right spot. And then a parenthesis at 3. Bracket at -1/2, parenthesis at 3. What questions do you have on the orange one? Okay. I want you guys to try this one, please. Yes, ma'am, that is correct. Would anyone else like more time? Okay. I'm going to go ahead and subtract 2 from all 3 of the sides. Boom. And then I got -2 is less than 1/2 x, which is less than or equal to 4. And then that's 1/2. I'm going to multiply everything by 2. So where everything else I divide, fractions you multiply. So I've got -4 is less than x, which is less than or equal to 8. So -4 is a parenthesis, 8 is a bracket. So the graph looks something like that. And your interval notation is -4, 8. What questions do you have? Okay. Now we have our ors. So if we scroll back up to our top, our ors, when we write our solution set, they're going to require a union symbol because we're going to be skipping some numbers. Okay, they're like our black, red, orange, blue examples here. Okay. Now with or inequalities, you solve them individually. Okay. You do the equation or the inequality on the left, and you do the inequality on the right, and then you just slap an or between the both of them. Okay. So I've got x minus 4 is less than -2. And I've got, or I've got technically, right? Or I've got 2x plus 1 is greater than 7. Okay. So I'm going to start here on the left. I'm going to add 4, and I get x is less than 2. Okay. Or I'm going to subtract 1. So 2x is greater than 6, and x is greater than 3 after dividing by 2. So x is less than 2. That's a parenthesis. Here's my 2. Less than 2. Parenthesis to the left. Greater than 3. Parenthesis to the right. And you can see in the graph the numbers we skipped. We skipped all the numbers between 2 and 3. And so we went from -infinity to 2 in union with 3 to infinity. And that union is where the gap is. I know for me that seeing this particular problem kind of helps me, seeing the graph helps me write the interval notation with or inequalities. I don't know, for some odd reason, it just helps me wrap my mind around it and I'm good to go. But that's me. Okay. What questions do you have on the blue problem? The light blue. Okay. All right, let's do another one. All right, again, we have two separate inequalities. So 3x plus 5 is less than or equal to -1, or x minus 2 is greater than or equal to 6. I'm going to solve the one on the right first just because it takes less effort. I'm going to add the 2. X is greater than or equal to 8, right? 6 plus 2 is 8. Or, right? I'm going to subtract 5. 3x is less than or equal to -6. Divide by 3, x is less than or equal to -2. Now, just because I got a negative answer doesn't mean I switch my inequality symbol. Only if you multiply or divide by a negative do you switch the inequality symbols. So x is greater than or equal to 8, so that's included. So bracket 8. And x is less than or equal to -2, that's bracket -2, and it goes less than. So on that number line, these are all the numbers that we have skipped. So we have to go from -infinity to -2, bracket, in union with bracket 8 to infinity. Okay? Questions on that one? Okay? Give that third one a go. Give that one a go. And don't be mad if you don't get this interval notation. It'll be fine. You got the values right. You're close on that. You're close, but it is not correct. I wouldn't be surprised. I'd be surprised if anybody gets this one. All right, go ahead and jump into this one. And I say that because it's like, just bear with me. So most of you probably solved the inequality and you're like, what is going on with this? Okay, this is something that can happen. Okay. So we're going to multiply by 2 here to get rid of that fraction. X is greater than 8. Or we're going to divide by -1. X is greater than or equal to 3. Okay. So you're like, okay, X is greater than 8. That's great. There it is. Parenthesis, boom. But X is also greater than or equal to 3, which is that. So what? Right? What? All right. Here's the dealio. The word or. Does it work for one or the other? Okay. This is actually only one interval notation. It's only one written item. You could probably deduce that we are going to infinity, but the problem is, do I put the 3 or the 8? Well, the 8 is and. The 8 works for the left and the right. Yeah, we are going to use the 3. Okay. But the word or says it needs to work for the left or the right. And the value that makes it work for left or the right is 3. So 3 to infinity covers all of my number bases. So the numbers 3, 4, 5, 6, 7, and 8 work for the right, but they do not work for the left. The numbers 9, 10, 11, 12, etc. work for the left and the right. Okay? But because it says or, it only has to work for one or the other. Okay? Questions, comments, concerns? Okay. Our next set of inequalities is absolute value inequalities. I teach this using an acronym called GO-LA. If you are a Lakers fan, it's going to be easy for you to remember because it's like, yeah, go Lakers, right? But there you go. So it's an acronym. GO stands for the greater than family with an or graph. Less than is LA stands for the less than family inequality symbols with an and graph. So if we have an absolute value inequality, I don't like basketball. You guys can chastise me for that later. All right. So we have the absolute value of X is less than 3. So that means this is an LA equation. Okay. It's the less than family inequality symbol, right? It's just the less than, has an and graph. What that means is the absolute value of X is less than, in this case, 3, even though it says A. That means this is going to be between -3 and +3. So this particular graph is from -3 to +3. So between. So LAs do betweens. So right here from -3 to +3, this is what an LA graph looks like. It's a between graph. Okay. The go, it's the greater than family inequality symbol. It's either going to be greater than or equal to with an or graph. Okay. So the absolute value of absolute value of X is greater than 3 is the same as saying X is greater than 3. That is definitely not a 3. Or X is less than -3. So you flip and negate. It's the flipping opposite. Okay? You take the flipping opposite. All right. So x is greater than 3 or x is less than -3. And so there's my or graph, right? Because we got our little guy. He's on his little boat and he's rowing his little oars. Ah, ah. Try the ribs. I'll be here all week. Anyway, so there you go. He's on his little boat, rowing his little oars with his little oar graph. And there you go. All right. So let's look at the first one. So with absolute value equations, it was two separate equations where you kept the left side the same and changed the right to the opposite. Absolute value inequalities are pretty much the same thing. This is a less than, so it is an and. Okay, this is an LA. So we're going to go x minus 2 is less than 5. And make sure you put that and in there so that we know that it's a between graph. And then you're going to take the flipping opposite. So you keep x minus 2 and then the flipping opposite. Keep the flipping opposite. Flip the sign opposite what's on the right-hand side. Okay? Add 2. X is less than 7. And add 2. X is greater than -3. So this guy is between -3 and 7. So there's our between graph. And so it is parentheses -3, 7, because you go from smallest value to largest value. Okay, questions on the purple one?
Can you go back up for a quick second?
To that guy?
Yeah, thank you. Okay, I got it now. Thank you.
You're welcome. Okay. Let's go to the third one here real quick. We're going to skip the second one. You guys are going to do that one. So we have, again, we have a less than. This is an LA, so it's a less than. It's going to be an and graph. So you have x plus 4 is less than -1, and x plus 4 is greater than +1. Keep the flipping opposite. So we're going to subtract 4. X is less than -5. And subtract 4. X is greater than -3. All right, so we're going over here. Greater than -3. Less than -5. What just happened? Is that what my graph is supposed to look like? It's a between. Is my graph supposed to look like that? Like this? It looks like that. It's not supposed to do that, is it?
Nope.
No, it's not. Okay. So guys, in this particular case, this is actually no solutions. Okay. There's no solutions because spelling is hard. No solutions. Okay. Because this is supposed to be a between graph. It's an and. It's supposed to be a between graph. But it gave me an or. Okay. It's supposed to be a between graph, but I got an or graph. So it's no solutions. How you write that in interval notation is an O with a line through it. Okay. What questions do you have on the brown one? Okay, I want you to do this guy, that guy there in the middle. Yes. Tried to check. Yes, both of you. Both of you are correct. Would anyone like more time? Okay, again, this is a less than, this is an LA. So you have 2x plus 1 is less than or equal to 3, and 2x plus 1 is greater than or equal to negative 3. Keep the flipping opposite. So you have 2x is less than or equal to 2, x is, excuse me, less than or equal to 1, and 2x is greater than or equal to negative 4, and x is greater than or equal to negative 2. So less than or equal to 1, boom, boom. Greater than or equal to negative 2, boom, boom. So there you go. It does meet the criteria. So it is negative 2, 1, both with brackets. Both with brackets.
How come the sign doesn't flip for the like last answers you got for both of them?
Because I divided by positive 2, even though I did get a negative answer, dividing by a positive does not cause me to flip my sign.
But only if like it feels like negative
If
2.
it was negative 2, yes, I would have flipped my sign then.
Thank you.
You are welcome. What other questions do you have? I don't care. Just as long as you know it's an and is the important thing. All right. So now we have greater thans. Okay. We have greater thans. So we've got, this is a go because it's a greater than. So it's a go. So you have x minus 3 is greater than 2, or x minus 3 is less than negative 2. Again, keep the flipping opposite. Add 3, x is greater than 5, or add 3, x is less than 1. Okay, greater than 5, boom. Yep, that works. Less than 1, boom, that works. It is an OR inequality with an OR graph, so we are good to go. I don't know why I put that on -1. Let me move that over there. Oh, I can't. Biscuits. I don't know why I put it on negative. It's supposed to be +1. There we go. Okay. So then go from smallest to greatest. So 1 is smaller. So we have -infinity to 1 in union with 5 to infinity. Okay. Questions on the black one? Okay. Yeah, that's the right one. Yes, that's the right one. Sorry, I wanted to make sure I did the other special case here. All right. So again, this is OR. So you have x plus 1 is greater than or equal to -4, or x plus 1 is less than or equal to +4, right? So you keep it, flip it, make it the opposite. Subtract 1, x is greater than or equal to -5, or x is less than or equal to 3. So greater than or equal to -5, boom, boom, that way. Less than or equal to 3, that way. So now this one, this is an and graph, but it's not supposed to be. It's supposed to be an or graph. So do we think this is no solution as well? Yes or no?
Yes.
Anybody else? Yes, okay. Anybody else?
No.
You're going no? There has to always be someone that says no. It's okay. I like you people. The no's have it. This is not no solutions. This is infinite solutions. Because technically, less than 3 keeps going and going and going, and greater than -5 also keeps going and going and going. So we've covered the entire number line. So if my OR inequality ends up with an AND graph, it's infinitely many solutions, so -infinity to +infinity. If my AND inequality ends up with an OR graph, it is no solutions. Crazy, right? Okay. do this guy. It should be negative infinity with the -6. And it should be written first because it is smaller. Would anyone like more time? Okay. Again, this is a go, so it should be greater and or. So I have 2x plus 5 is greater than or equal to 7, or 2x plus 5 is less than or equal to -7. Okay, going to subtract 5, so 2x is greater than or equal to 2, and then divide by 2, x is greater than or equal to 1, or subtract 5, 2x is less than or equal to -12. Divide by 2, x is less than or equal to -6. So less than or equal to -6, bracket -6, greater than or equal to 1, bracket on the 1. Okay. The big thing here, write these smallest to largest. -6 is smaller than 1. So you have to write the left side of this inequality first. So it goes negative infinity to -6 bracket and union with bracket 1 to infinity. Okay? Questions, comments, concerns, discrepancies, complaints to management? One more lesson, functions and relations. Start off with a big old chunk of vocabulary here. Relation is a set of ordered pairs. A function is a relation where the domain has exactly one output. The input has exactly one output. Input is domain, output is range. Domain, there we go. The set of all values x for which the function is defined. Range, the set of all values of y for which the function is defined. And functions can be represented as ordered pairs in a table or list, graphically or algebraically. So there's different ways to represent functions. Okay? We have something for functions called the vertical line test. It's a method of determining if a relation is actually a function by drawing a vertical line on an existing graph of a relation to see how many times the graph relation passes through the vertical line. If a vertical line passes through the graph of relation more than one time, the relation has failed the vertical line test and is not a function. Okay? You fail. You are not a function. When a relation is determined to be a function, then the function can be written using the notation f parentheses x equals, read as f of x instead of the standard y equals. So f of x and y, they are interchangeable. F of x is y. Okay? The x-intercept is where the function crosses the x-axis and the y value is equal to 0, written as an ordered pair, x comma 0. With any function, there can be 0, 1, or infinite amount of x-intercepts. Y-intercept, where the function crosses the y-axis, the x value is equal to 0, written as an ordered pair, 0 comma y. With any function, there can be only 0 or 1 y-intercept. Notice that the stipulation says with a function. Function. If it is not a function, it can have an infinite amount of y-intercepts. But if it is a function, it can only have none or one. Okay? Horizontal line test is a method of determining if a function is a one-to-one function by drawing a horizontal line on an existing graph of a function. See how many times the graph function passes through the horizontal line. If a horizontal line passes through the graph of the function more than one time, the function has failed the horizontal line test and is not a one-to-one function. Boom. So there are functions and there are one-to-one functions. For the record, one-to-one functions have inverses. Regular just function without the words one-to-one do not. Okay. So we got four little doohickeys here. Okay. Determine if each relation is a function. If the relation is a function, then determine if the function is one-to-one, is a one-to-one function. Okay. So there's your four different things, right? Four different doodads, four different problems. Okay. So first off, is it a function? It only has to have, it can only have one of the one individual x values. If there's more than one x value that is the same, it's not a function. So I've got 2, 3, 2, 4. I've repeated the 2. So this is not a function. Because the x value of 2 repeats. There's more than one 2. You can't have that. That's a no-no. Okay. All right. So on the one on the right, so I got 1, 2, 3, 4. So it is a function because no repeated x's. All right. Now, to be a one-to-one function, it has to have no repeated y's. So 10, 20, 30, 40. So it is a one-to-one function. Okay. So it's a function because there were no repeated x values. It's a one-to-one function because there are no repeated y values. So if you're given a set of ordered pairs, that's how you determine it. If you're given a picture of a graph, you're going to draw a vertical line, preferably a straight one. Let me use my let me use my little tool here. Okay. So there's my vertical line. 90. There it is. All right. There we go. So this guy is a function because it passes the vertical line test. Okay. So this is a function. Okay. It passes the vertical line test. Okay. So now we need to determine if it's a one-to-one function. So we're going to draw a horizontal line. So horizontal line, boom. No, 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 no. There we go. And you can see that it only crosses the function one time. So again, it's a one-to-one function. Because it passed the horizontal line test. Okay. So not only is it a function, it is a one-to-one function. All right, we got a circle here. So we're going to draw my vertical line. T, 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 T. All right, boom, boom. It passes through the function, or I'm sorry, the relation 2 times. So this is not a function. It failed the vertical line test. Well, if it's not a function, it definitely can't be one-to-one. Okay. What questions do you have? Okay. All right. So evaluate the function for the given values. Basically, what is the value of y when x is 3? That's what that says. Okay, so what is the value of what does y equals when x is 3? So f of 3 means we're going to plug 3 into the equation. So it becomes 3 squared minus 3 times 3 plus 5. Well, that's 9 minus 9 plus 5, which is 5. So the value of the function, the y value of the function when x equals 3 is 5. Okay. Same thing here. What is the value of the function when x is -2? So f of -2 is equal to -2. Again, notice I'm using parentheses. -3 times -2 plus 5. So that's 4 plus 6 plus 5, which in this case is 15. So f of negative 2 is equal to 15. Okay. Questions on the blue or the purple? Okay. Plug in negative 1. So f of negative 1 is equal to 2 times negative 1 squared plus 3 divided by negative 1 squared. So that is negative 1 squared is 1. So 2 times 1 plus 3 over 1. So 2 times 1 is 2. 2 plus 1 over 1, which is 3 over 1. So f of negative 1 to, to 2 plus 3. Where did the 1 go? What am I doing? I don't know why I made that 3 a 1. I was just like, no, I really want it to be a 1. 2 plus 3 is definitely 5. So f of negative 1 here is 5. I was just excited writing ones, I guess. Why don't you guys try the one on the right? Try f of 0. Correct. Yes, correct. You shouldn't need too much time on this one. And here's why. Because first off, 0 squared plus 3, right? Like 0 times anything, or yeah, 0 times anything is 0. So f of 0 here is 0 plus 3 over 0. And f of 0 is equal to 3 over 0. Can I do this? Can I have 0 in the denominator?
No.
No, you can't. So your answers are going to be no solution, undefined, empty set, anything like that. I'm just going to put that guy right there. No solution, undefined, whatever you want to call it. It's a null set. Okay. Remember, you cannot have 0 in the denominator. Okay. Questions on the pink one? Now, it's great when the functions are right like that, but what about this one? I've got two different functions. This is a piecewise function. Well, piecewise, it's like, okay, well, how do I know which one to plug it into? You plug it into the one that the x fits what is called the restriction. So my restrictions here are x is less than 0 and x is greater than 0. Greater than or equal to 0, sorry. Ugh, I feel like I'm going to start sneezing again. Okay? So these guys are the restrictions. Your job is to find out which restriction fits your x value, so you pick that equation. So how about when x is -4? If x is -4, is it less than 0 or greater than or equal to 0? Hello? Is this thing on? When x is -4, is that less than 0, greater than or equal to 0?
Less than.
Thank you for answering. Someone. All right, it's less than. So because it is less than, we use the top equation. So this one, f of -4, would fit into 2x plus 1. So we're going to go 2 times -4 plus 1. So -8 plus 1. So f of -4 is equal to -7. What about when x is 0? Like down here in the bottom right, when x is 0. Is that less than 0, greater than or equal to 0?
Great.
It's
Equal
greater
to?
than.
Greater than. Greater than. And the reason it's greater than is because we do the equals, right? So it's greater than or equal to 0. So that's that bottom one. 0 equals 0. So we're going to use our 2x minus 1 here. So f of 0 is 2 times 0 minus 1. So f of 0 is -1, right? So it just kind of does that. Okay? All right. Why don't you guys do the two that remain? Would anyone like more time? All right, 0.5 is greater than equal to or greater than or equal to 0. So you're going to use the 2x minus 1. And it's 2 times 1/2 minus 1, which is 0. And then if x is -1, that's less than 0. So you're going to use the 2x plus 1. So that's 2 times -1 plus 1, which is -1. Questions, comments, concerns? All right, so now we're going to start doing some Domains. Domains and intercepts. Shouldn't be too long. Oh, wait, nope, just kidding. I forgot about this problem. Okay, so this particular problem, um, it's we're going to substitute in x plus h and then subtract the original function. So that's what this means. Sub in we're going to sub into the function x plus h, then subtract the original function. So it looks something like this. 2 times x plus h squared minus 3 times x plus h plus 5. All of that in a bracket by itself, minus the original function, 2x squared minus 3x plus 5. Okay? I do need to FOIL this guy. I'm going to FOIL it over here. So x plus h times x plus h. So we have x squared plus xh plus xh plus h squared. So this is 2 times x squared plus 2xh plus h squared minus 3 times x plus h plus 5 minus all of this again. 2x squared minus 3x plus 5. Okay? Now, we're going to have to mess around with this later. But I tend to distribute all at once. Yes, I could have distributed a lot sooner, but I tend to distribute all at once. So now I'm going to distribute the 2 into that parenthesis, the -3 into that middle parenthesis, and the -1 to that end set of brackets there. So I end up with 2x squared plus 4xh plus 2h squared minus 3x minus 3h plus 5 minus 2x squared plus 3x minus 5. And then I'll combine like terms. 2x squared and 2x squared go away. Negative 3x and positive 3x go away. Positive 5 and negative 5 go away. And that's it. I'm left with 4xh plus 2h squared minus 3h. Left with that, that, and that. And that is your answer for now. For now. We will do more with that later. I'm trying to remember when. But it will be on your midterm, so I know we cover it before your midterm. Which means it's also on your final. If it's on your midterm, it's also on your final. And again, remember guys, the final is 2 days. So make sure you sign up for both days for the final. One day ain't gonna cut it. All right, questions on that one? All right. Identify the domain of each of the given values. Give your answer in interval notation. The domain has no denominators equal to 0 and no negative values under an even radical. Most of the time we just do square roots, but if you happen to see a 4, a 6, a 3, 5, 7, etc., just so you know. Okay? So it doesn't rightly matter what my numerator is because numerators being 0 is perfectly fine. It's when denominators are 0 that there is a problem. Okay? So even though my numerator is 6x squared plus 12x minus 24, we don't care. Leave it alone. Okay? We care about that denominator not equaling 0. So 2x plus 9 cannot equal 0. 2x cannot equal negative 9. And x cannot equal negative 9 over 2. Okay? All right. So essentially, my domain is all real numbers except negative 9 over 2. The domain is all real numbers except negative 9 over 2. Now, your job is to turn those words into interval notation, which means I go from negative infinity to negative 9 over 2, and I skip it with a parenthesis, and then from negative 9 over 2 to infinity. That is your domain. It does not matter if that numerator turns to 0. It matters if the denominator turns to 0. Okay? For this other one, that denominator, we're going to factor that guy. So boop, boop. What multiplies to give me negative 6, subtracts to give me negative 1. 2 minus 3. So this is actually f of x is equal to 1 over x plus 2, x minus 3. And again, we do not want that denominator to equal to 0. So x plus 2 cannot be 0. So that means x cannot be negative 2. And then x minus 3 cannot be 0. That means x cannot equal 3. Okay? So my domain is all real numbers, everything except negative 2 and 3. So it's all real numbers except negative 2 and 3. And your job is now to put that in interval notation. And all real numbers start at negative infinity. So negative infinity to negative 2 in union with, because we're skipping stuff, negative 2 to 3 and union with 3 to infinity. So I've hit every number between negative infinity and positive infinity except negative 2 and 3. Questions on that one? Okay. I will factor this third one for you, but then I want you guys to write the domain. So again, it's the denominator. We're just going to pull out the greatest common factor. So we got 3x minus 7, and the greatest common factor is 12x. So we're left with x plus 2. All right. So I want you guys to just write the domain. Write the domain of that purple function there that I factored. Would anyone like more time? Okay. Guys, x cannot be 0 and x cannot be -2. So your domain goes from -infinity to -2 and union with -2 to 0. Whoops, that's definitely not a 0. To 0 and union with 0 to infinity. So it's all real numbers except -2 and 0. Questions on the purple one? Okay. The square root, that guy right here, whoopsie poopsie, is an even radical. A square root is an even radical. So that means in this case, it can be 0 because the square root of 0 is 0. So under a radical, it has to be greater than or equal to 0. Okay? So you got 2x is greater than or equal to 7, and x is greater than or equal to 7 over 2. In this case is 3.5, right? Okay. So if it's greater than or equal to 7 over 2, then it's bracket 7 over 2 to infinity. And there you go. Questions on that one? Okay. G of x here, that's the cube root of -x to the fourth plus 3x squared minus 10. It's like, oh my goodness, that's crazy. The domain here is all real numbers. Okay. The domain is all real numbers because the radical is odd. 3 is an odd number. Your rule for radicals only applies to even radicals. 2, 4, 6, 8. 3 is odd. Okay? Try the one on the right. Would anyone like more time on that one? The black one? No, that is incorrect. You're dividing by -1, so you have to flip the sign. So it's less than or equal to 0, and then subtract 6. So it's less than or equal to -6. So it's all real numbers less than or equal to -6. So it's -infinity to -6. If you did forget to flip your sign, you would have gotten greater than -6. But don't forget, when dividing and multiplying by a negative, you have to flip that inequality symbol. Questions on the black one? Okay. The domain and range of the following functions, guys, these are just from graphs. Okay. Remember, the domain is the x values, the range is the y. Oh my goodness. Okay. So the domain is how far it goes left to right. So that's left to right. And the range is how far it goes up and down. So if I'm looking here at my graph here, the furthest it goes to the right is 3, but it's not included. So that's a parenthesis 3. The farthest it goes to the left, there's an arrow down here. That is -infinity. So my domain is -infinity to 3. My range, as low as it goes, again, there's an arrow, that's -infinity. The highest it goes is right there at 2, and it's a solid line, so we're going to make a bracket. The only reason we didn't make the 3 a bracket is because that is an open circle, and open circles are not included. This is an absolute value function. The domain is all real numbers. And the range, the highest it goes is 1, and the lowest it goes down there with those arrows is -infinity. So this is from -infinity to 1 bracket. This little curvy guy is a quadratic. The domain of all quadratics is -infinity to +infinity. The range is the highest or lowest point. In this case, the highest point is 3, and the lowest point is infinity. So this is -infinity to 3. And this little fella on the right is a cubic, and the domain and range of a cubic are always all real numbers. So negative infinity to positive infinity. So cubics are pretty nice. Oh my goodness. There should have been a bracket on the range of that quadratic. I'm sorry. It should be negative infinity 3 bracket because it's not dotted or anything like that. Okay. Questions on the domains and ranges of graphs. Last thing, X and Y intercepts. Determine the X and Y intercepts for each of the following functions. Write your answers as ordered pairs. So the X-intercept is when Y equals 0. So Y is equal to 0 here. X-intercepts when Y is 0. Y-intercept is when X is equal to 0. So the X-intercept, we're going to go with 0 is equal to 3 over 2X plus 3. Subtract 3, so negative 3 is equal to 3 over 2x. Multiply by the reciprocal 2/3. And the answer here is negative 2 is equal to x. Write it as an ordered pair. Y is 0. So my x-intercept is negative 2, 0. Y-intercept is when x is 0, so you get y is equal to 3 over 2 times 0 plus 3. And 3 halves times 0 is just 0, so y is equal to 3. And write that as an ordered pair. X is 0, so this is 0, comma 3. Questions on the green one? Okay. Let's skip down here to the rational ones. We will have to do these later in the unit or later in the semester, term, whatever you want to call it. Okay. X-intercept is when y is 0. So 0 is equal to x minus 4 over x plus 1. If you multiply by x plus 1 to get rid of your fraction, what's 0 times x plus 1?
0.
0, right? So it's 0 is equal to x minus 4. Add 4. 4 is equal to x. So in this case, my x-intercept is 4, 0. So with rational functions, to find the x-intercept, you just set the numerator equal to 0. Y-intercept, again, x is 0. So y is equal to 0 minus 4 over 0 plus 1. Y is equal to negative 4 over 1. Y is equal to negative 4. So this is 0, negative 4.
Wait,
Yep.
one question. How did we cancel out the denominator on the left side with x-intercepts if the denominator of like fractions can never be 0?
The denominator's not 0. The x-intercept, so the x-intercept is just where does it cross the x-axis? that has no bearing on whether or not the denominator is 0. But just like with, if that was 1/2, right? That was 1/2 equaled 0. I'd multiply by 2 and multiply by 2.
Oh, okay.
Right. So I'll just say x. Okay. And that would go
Yeah.
away and x would equal 0, right?
Mm-hmm.
So just like with solving an equation with like numbers or whatever, you can multiply binomials and get rid of that part of your fraction so that it's easier to work with. Okay. X-intercept, y is 0. Oopsie poopsie. 0 is equal to the square root of x plus 4 minus 1. We're going to add 1. 1 is equal to the square root of x plus 4. To get rid of a square root, we are going to square this. Well, 1 squared is 1. And then you get x plus 4. Subtract 4. -3 is equal to x, so it's -3, 0. And the y-intercept, x is equal to 0, so y is equal to the square root of 0 plus 4 minus 1. Y is equal to the square root of 4 plus 1, and I'm sorry, minus 1. I got really excited with those plus signs there. The square root of 4 is 2. Y is equal to 2 minus 1, and 2 minus 1 is 1. So this guy is 0, 1. And that, shoo, is all for today. Questions, comments, concerns, discrepancies, complaints to management?
I got a complaint to management.
Yes,
I'm
dear.
just kidding. I'm just kidding. No, but I was just gonna say how so I did the I think the midterm I already registered for it for like
Okay.
November 20th. I think that's 2 weeks from now. Yeah. Today's the
Yeah,
6th.
somewhere in there. Yeah.
Yes. So I don't have to I can make the appointment like before the week of, like right before it, right? Like for the final exam.
You can already schedule your final exam right now. It's open.
Well, I know, but like I could there's no deadline, right? It's just like before like you're able to take the test, right?
No, there's a deadline for the final exam. You can only take it during the week of, let me look at my calendar. So the final exam, so the midterm you have to take between the 17th and I think the 21st or the 20th. The final exam you have to take December 15th through December 19th. I'm sorry, December 18th. Maybe it's the
Oh,
19th.
sorry. I think I
That week.
specified it wrong. So, okay, so you do have to take it that week, but I can register for it like the 13th, right? Like there's no deadline to register for it. That's what I was
There's
asking.
not, but the longer you wait, the less likely you are to actually get a spot. And then
Okay.
that starts stressing people out.